this area has benefited by adopting deep learning approach. One of the recent trend in deep learning is replacing the feature extraction module, which we currently do by signal processing, by deep learning itself. That we call it as a feature representation learning, or in short, we call it as representation learning. Also, once some of these major technologies like speech recognition, speech synthesis, and speaker recognition started giving a very good performance, they are exploring many applications much beyond the normal transactions, business transactions like thing. For example, one potential direction for exploiting speech is using speech processing for healthcare applications. I'll take that as a case study and illustrate how the the recent trends or recent very good performance in some of the speech technologies can be exploited for healthcare analysis also. This one slide taken from a public domain will illustrate the change that has happened in the last 1 decade. You can see there is a steep slope in the speech recognition technology in the last 1 decade, specifically starting from 2012 to till now. You can see the performance of the system has increased steeply in this last 1 decade compared to the other journeys from starting from early 90s to till 2012. Of course, this is the performance of speech recognition is measured in terms of word error rate. The word error rate has decreased. Lower the word error rate, better is the performance of the speech recognition system. Accordingly, in the last 1 decade, the word error rate has decreased significantly. When you see when it is below 5% or something, it has approached to the human level performance. Even humans, due to many reasons, may not be able to decode all the words.
There is a periodic structure, so that will be reflected in the periodic structure in the frequency domain. This periodicity in the time domain signal is coming basically because of the periodicity in the vocal fold vibration. So using this, you can derive pitch easily from the spectrum. There are so many methods. So this is about the extracting the pitch from the speech signal using a spectrum. So I will skip this. Yeah. Okay, now I will explain for this some few applications, whatever we have seen earlier information. So here I'm showing for a simple for 4 applications, like a neutral speech is whatever I'm speaking now. Phonation type means like a breathy voice. What is happening right now? That is a breathy phonation, or tense phonation like a stress voice and other stuff. Emotions all people knows like anger, happy, like this. And then expressive singing, because we'll be saying singing has a lot of emotions. So can we analyze some of this information? Non-verbal means like a laughter or shout. We don't have to understand the text. Suppose people will be laughing. So that means there is no speech, only laugh is there. That is coming from the speech production. So we can analyze what is happening in the laugh. So these are arranged basically, suppose in neutral, there is no emotion. Non-verbal means only emotion. There is no text or verbal content. Whereas in the singing is more dominant compared to lyrics. In the emotion, both the text, that means verbal content, and non-verbal, like emotion, both important plays a role. So less than that is a phonation types. That is also known as a voice qualities. So this we have seen already, so I will skip that. So for example, here I'm showing a plot for the 3 types of phonation. Breathy means whatever I have produced. What is happening right now? Are you feeling good? So that is a breathy voice. Press is like a more stress. What is happening right now? So I'm not producing properly, like you can guess like a more stress voice. Modal means normal, like whatever I'm speaking now. So you can see that this is at 1 frame. If you take,
rely on 3 key statistical rules. One is the base rule, the first, which many of you would have come across in your pattern recognition studies, and if you do probabilistic and statistics, you are going to come across the base rule. Second rule is about the marginalization rule, where if we assume that there are k classes of bk and they are mutually exclusive and collectively exhaustive, this is important there, and then we can actually estimate the marginalized distribution from a joint distribution. This second rule. And the third rule is about gift sampling. If you have a sequence like B1 to BK to BK and a collection of vectors, then you can write them in a conditional manner as a multiplication of conditional likelihoods. So in this talk, what we are going to see is that we will be using this kind of rules. I am not going to be explicitly saying which rule and all, but most of the things what we see are going to be built around these rules. So the talk I have structured is around on the problem of sequence classification, which is like sequence to sequence prediction, which is automatic speech recognition, where we will see that, okay, we have a sequence of acoustic features and or representation, or you have even the signal sometime, and then you want to predict a sequence of words there. And then there is another case I take is what is called hypothesis testing problem, which is what is the speaker verification problem. I will touch upon that on that point. So in a way, we can construct this what we call the speech recognition problem as a finding from a set of hypotheses. So if you have an input speech signal S and you have a set of hypotheses,
folders like utilities, steps, local, conf, cmd.sh, path.sh, and runswitchdemo.sh, and a corpus. Rest of the things, data demo, demo feeds, experiment demo, these will be created when the experiments run for you. Okay, I have done this just to check. So what these folders have, okay, the conf folder will have something called mfcc.conf. Like in speaker verification, we had mfcc.conf. We need an mfcc.conf over here also. Right now, there is no entry except that my use minus energy is equal to false. Otherwise, you can, like in speaker verification, mention the sampling frequency, mention the number of MEL filter banks, mention the number of Capstell coefficients, and everything else. If you don't do that, what actually is going to happen is it's going to take all the default values. So let me open a terminal. Let me navigate to the Kaldi toolkit. So this is my top level directory. What I'm doing is I'm going to show you. This is the binary file which executes and extract your MFCC features. So if you run this, you'll see there are a lot of options given to you. So if you mention these options in your conf file, that particular thing will be given a different value. Like if you allow down sample, by default this is false. If you allow it, make it true, then it do down sampling of the data. Okay, similarly there are Capstell lifter, how many you want. By default it is 22. You can change it if you want. So all these things like frame length, by default it is 25. Frame shift, by default it is 10. High frequency, number of melbins, all these things. Number of Capstell, by default it is 13. Number of melbins, by default it is 23. Similarly, sampling frequency by default will be 16,000. Sample frequency, yeah, by default it is 16,000. So if you do not mention anything over here, then by default it is going to take the default values. Okay, so since our database that we are dealing with has got data which is sampled at 16 kilohertz rate, therefore 16 kilohertz rate, therefore you do not need to specify. Otherwise, if you remember, yesterday we were dealing with data which was sampled with at 48 kilohertz, and therefore sampling rate was specified in your conf file. Okay, so this is what the conf folder has. There are there are other things also, like MFCC high resolution conf, online capsule mean and variance normalization conf, online pitch conf, q number k20.conf, decode.conf. These all depends upon what kind of code you are calling. If you are doing high resolution MFCC feature computation, then we go for this conf. If you are doing online capsule mean and variance normalization, you need this. If you are doing MFCC plus pitch or PLPC plus pitch or filter bank plus pitch, then you need this configuration. Right now, you just need this configuration. Okay, so this is the conf file we need. Like in the speaker verification case, the data folder will have a test folder